Last time when we discussed that y is the function of x, here the dependent variable y, it depends on only one independent variable, that is x. Today I want to discuss about the bivariate function where the dependent variable z, it depends on two independent variables. One is x, another one is y. So in this case, if we want to find out the derivative of that function, we have to find out the derivative of that function with respect to two variables. One is x, another one is y, and we call that derivative as partial derivative. For example, if we want to find out the partial derivative of z with respect to x, we denote it by delta z by delta x. In this case, we have to treat y as the constant. Similarly, if we want to find out the partial derivative of z with respect to y, we have to treat x as constant, and we can denote it by delta z by delta y. So now you understand that when the function is a bivariate function, if you want to find out the derivative, we call that derivative as partial derivative, and when we find out the derivative of that function with respect to one variable, we have to assume that another variable is constant. Okay, so this is actually the notation used to represent the partial derivative of this function with respect to x are delta z by delta x df by delta f by delta x. Delta delta x is function of x y, or fx f or zx. So now similarly, this is the notation to represent the partial derivative of this function with respect to y, delta z by delta y, delta f by delta y. Okay, these are the notation. But here remember that when we use dz by dx, it represents the derivative of a function of one variable x. But when we represent delta z by delta x, it represents the partial derivative of a function of two or more variables. Okay, so this is the bivariate function. Okay, where the dependent variable, it depends on two independent variables. One is x, another one is y. So the function is x square minus y square then whole square. Then we have to find out fx and fy. That means the partial derivative of this function with respect to x, and this one with respect to y. In the previous slide, I mentioned to you that when I want to find out the partial derivative of the bivariate function, then we have to find the derivative of that function with respect to one variable. For example, here if we want to find out with respect to x, we have to assume that y is constant. Similarly, when we want to find out the partial derivative of that function with respect to y, we have to assume that x is constant. So let's do this one. So fx, it will be, so you know that this is the power of the function rule. So we have to bring the power 2 in front, then write down the function, then to the power 2 minus 1, it is 1, and then the derivative of this function. Okay, so here since y is constant, so the derivative of y square will be 0, because you know that the derivative of the constant number is 0. So the derivative of x square will be 2x. So after multiplication, you will get 4x to the power 3 minus 4xy square. Similarly, if I want to find out y, okay, if y, that means the partial derivative of this function with respect to y, then x is constant. So now follow the rule. Okay, you have to bring the 2 in front, then write down the function, then to the power 2 minus 1 times with the derivative of x square, it will be 0 because x is constant, and derivative of minus y square, it will be minus 2y. Okay, then after you multiply with 2 with this function, we will get minus 4x square y plus 4y to the power 3. Similarly, here suppose this is the function, and here you see that this is a fraction, that means we have to follow the quotient rule. Only the difference here, when you want to find out the since it is bivariate function, if you want to find out the partial derivative with respect to one variable, you have to assume that another variable is constant. So let's do it. So it will be delta q by delta p1, okay, because you have to find out, okay, this is the bivariate function, you have to find out delta q by delta p1. Okay, it will be equal to Okay, follow the quotient rule. First we have to write down this one, p1 p2 minus 2 p2 times with the derivative of this one. Now you see that we are finding the partial derivative with respect to p1. That means p2 is constant here. Okay, so the derivative of this function, it will be, okay, p1 p2, since p2 is constant, so p2 times the derivative of p1, which is 1, then plus, okay, plus 2, the derivative of p1 is 1, so 2 times 1 is 2, then minus, you have to now write down this one, okay, p1 p2 plus 2 p1 times with the derivative of this one. Okay, so the derivative of p1 is p2 is constant, so p2 times the derivative of p1 is 1, then minus 2p2, here 2 is constant, p2 is constant, so the if you times two constant number, it will be a constant number, so that's why the derivative of minus 2p2, it will be 0. Okay, so only we will get from here, it is p2, then divided by, okay, this one whole square. Okay, after you simplify the function, you will get minus 2 times with p2 plus 2, then divided by p2 times p1 minus 2 whole square. Okay, now next slide we see another example. Okay, now here another example. Find the partial derivative of this function x square plus 3xy plus 4 with respect to x at the point 1, 2 and 11. So 1 is the value of x, 2 is the value of y, and for these two independent variables, we will get the value of the dependent variable, which is 11. So now let's do it. So this is the partial derivative of this function with respect to x is equal to, the derivative of x square is 2x plus 3 and y is constant. Okay, constant times the derivative of x is 1. Then the derivative of 4 is 0. So now in the next step, I have to substitute the value of x and y into this partial derivative. So it will be the partial derivative for this value of x and y, 1 and 2. We substitute x equal to 1 here, 2 times 1 plus 3 times the value of y is 2. So 8 is the answer. Okay, now this is actually the second partial derivative. What is actually second partial derivative? For example, if I want to find out zxx, that means first I have to find out zx, that means the partial derivative of the function with respect to x. Then again I have to differentiate zx with respect to x. So I will get, okay, this zxx. And then if I want to find out zyy, that means first I have to find out zy, then I have to differentiate zy with respect to y. Okay, so then zxy, in this case I have to first find out zx, then I have to differentiate zx with respect to y, and then lastly zyx, I have to first find out zy, then I have to differentiate the zy with respect to x. So that means here you see that both derivatives taken with respect to x, because this is x and x. Here both derivatives taken with respect to y, because this is zyy. Here the first derivative taken with respect to x, so that's why x first, then second derivative with respect to y. Okay, lastly first derivative taken with respect to y, then the second derivative with respect to x. So you have to follow this one, the order yx, xy, yy and xx. Here this is the example of the second order partial derivative. Suppose this is the bivariate function, z is equal to x to the power 3y minus 3xy square plus 4. We have to find each of the second partial derivative of the function. So the solution is like, first you have to find out zx, okay, with respect to x, then y is constant. So try to find out this one. So it will be 3x square y, because y is constant, minus then 3y square times with x, the derivative of x, it will be 1. So that's why it will be minus 3y square. Similarly, when I want to find out zy, remember that x is now constant. So x to the power 3 is constant, times with the derivative of y is 1. So that's why x3 minus, here 3x is constant, the derivative of y square is 2y. So 3x times 2y, it becomes 6xy. Now I have to find out zxx. So that's why I mentioned to you, if I want to find out zxx, I have to differentiate zx with respect to x. Now y is constant, so if y is constant, okay, then this is like y times the derivative of 3x square, which is 6x. So that's why 6xy. And if I want to find out zxy, that means I have to differentiate this one with respect to y. Now x is constant, okay, so it will be 3x square times with the derivative of y is 1. So that's why it is 3x square. Then minus the derivative of 3y square is 6y. Now I have to find out zyy. That means I have to differentiate zy with respect to y. Now x is constant, so the derivative of x to the power 3 will be 0 because this is constant number. Then the derivative of minus 6xy, since x is constant, so it will be minus 6x times with the derivative of y, and the derivative of y is 1. So minus 6x times 1, it will be minus 6x. Now we have to find out zyx. That means we have to differentiate zy, okay, with respect to x. So now y is constant. So the derivative of x square, it will be 3x square minus, here you know that y is constant, so it will be minus 6y times with the derivative of x, which is 1. So then we will get minus 6y. So this is the way how we can find out the partial second order partial derivative. So similarly we can do this one, okay, follow just this one. Okay, so now you see that in this example we are giving you the joint cost function for two product. Why this is joint cost function? Because here actually we are given two product, one is x, another one is y. So that's why when we want to find out the cost function, it will be joint cost function. That means the combination of cost of product x and combination of the cost of product y. So that's why see, this is the joint cost function. It depends on the quantity of x and quantity of y. So it is 50 plus x square plus 8xy plus y to the power 3. Here x represent the quantity of product x and y represent the quantity of product y. Now you have to find out the marginal cost with respect to the number of units of, for example, product x. So now you have to find out marginal cost with respect to the number of units of product x, which is actually we call it delta c by delta x, or we can write down mcx. Okay, so it is equal to, remember that this is with respect to x, that means y is constant. So the derivative of 50 is 0, the derivative of x square is 2x, and here 8xy, 8y is constant, the derivative of x is 1. So 8y times 1, it will be 8y. So this is actually the marginal cost with respect to x. Then this is the marginal cost with respect to the number of units of product y, that means delta c by delta y. We write it as mcy. Okay, so it will be, now remember that x is constant. So if x is constant, the 50 is constant number, the derivative of 50 is 0, x square also 0, the derivative of x square. Here 8x is the constant times with the derivative of y, which is 1. So that means 8x times 1, it will be 8x, plus the derivative of y to the power 3, it will be 3y square. Now the third question, that product x at 5, 3, that means you have to find out the the cost with respect to x, okay, when x equal to 5 and y equal to 3. So that means you have to, this is the marginal cost with respect to x, so this is 2x plus 8y, so that means you have to substitute x equal to 5 and y equal to 3. So after substituting we will get 34. So how do you interpret this result? The interpretation will be, if 5 units of product x and 3 units of product y are produced, because we are mentioning that 5 units of x and 3 units of y are produced, then the total cost increase approximately $34 for a unit increase in product x, because y is held constant. So that is the interpretation of the marginal cost with respect to x if it is 34. Similarly, we can find out marginal cost with respect to product y when x equal to 5, y equal to 3. So after you substitute, because this is the marginal cost with respect to y, we get this one. Now I substitute x equal to 5, y equal to 3, then we will get 67. How to interpret? That if 5 units of product x and 3 units of product y are produced, the total cost will be increased by $67 for a unit increase in the product y. And remember that here x is constant. So now let's go to the next slide. Okay, here you have to do like this is the production function. Z is equal to 5x to the power half, y to the power 1 by 4. You have to find out the marginal productivity of x and y. So this is production function where Z, suppose this is the production, it depends on two factors. One is x, another one is y. So now before that, just I briefly explain what is actually called the marginal productivity of x. Okay, this is actually delta z by delta x. That means if you increase x 1 unit, how much change in the in the z, that is called the marginal productivity of x. But remember that in this case y should be constant. Okay, again I am telling you that how much change in the z due to the 1 unit change in x, that is called marginal productivity of x. Similarly, what is called marginal productivity of y? It is delta z by delta y. So here how much change in z due to the 1 unit change in the y. Remember that here x is constant. Okay, so now here in this case we have to find out the marginal productivity of x and y, where the marginal productivity of x, which is delta z by delta x, it is equal to here 5, then times you have to find the derivative of x to the power half, which is half times x to the power half minus 1, which is minus half. That's why we can write down 5 by 2 x to the power minus half, then times with y to the power 1 by 4, because y is constant here. So this is the marginal productivity of x. Similarly, I can find out marginal productivity of y. Here you see that it is delta z by delta y, and then here x is constant, so you have to write down like 5 times here the y, it has power 1 by 4, so you have to bring 1 by 4 in front, so it becomes 5 by 4, then times with x to the power half is constant, then times with y to the power half 1 by 4 minus 1, which is minus 3 by 4. So that is the marginal productivity of y. So note that marginal productivity of x is positive for all values of x, but it decreases when x gets larger, because of the negative exponent. You see that it has negative exponent. The same is true for the marginal productivity of y. That means that the marginal productivity of y it is positive, but all values of y but that it decreases when y gets larger, because y it has negative exponent. Okay, so now let's go to the next slide. Okay, here this is another application of partial derivative. Suppose this is the demand function for a pair of related product 1 and 2. So Q1 is the function of P1 and P2. So you see that the demand for product 1 does not only depend on the price, its own price, also it depends on the price of another product. Similarly, demand for product 2, it does not depend on its own price, also it depends on the price of product 1. So we have to find out the partial derivative of Q1 and Q2, and where we find out the partial derivative of Q1 and Q2, they are called marginal demand function. For example, the marginal demand will be the partial derivative of this function with respect to P1, which is delta Q1 by delta P1. So this is the marginal demand of Q1 with respect to P1, and it is less than 0. Why? Because the demand for product 1, it has inverse relationship with its own price. That's why when quantity of it decreases when the price of product 1 increases. So that's why they have inverse relationship, and it is less than 0. Similarly, this is the marginal demand of Q1 with respect to P2, but it can be positive and it can be negative. Okay, later I will discuss this one. And this is the delta Q2 divided by delta P1. It is the marginal demand of Q2 with respect to P1, and it can be also positive or negative. And this one, delta Q2 divided by delta P2, this is the marginal demand of Q2, and it is also less than 0, because the demand for product 2, it is inversely related with the price of product 2. So that's why they have an inverse relationship, and it is always negative. So now you see that if delta Q2 divided by delta P1, that means marginal demand of product 2 with respect to P1, and this is the marginal demand of product 1 with respect to P2. If these two are positive, okay, then we can say that the two products 1 and 2 are competitive product. And if these two are negative, then we can say that the two products are complementary product. And if suppose this one positive and this one negative, or this one negative, this one positive, it indicates that product 1 and 2, they are not related. Okay. So now next slide we discuss one exercise. Okay, this is one example of the just now we see, okay, for competitive and complementary product. Okay, suppose this is the demand function for two product 1 and 2. Okay, Q1 is equal to 400 minus 5P1 plus 6P2, and this is the demand function for product 2. Q2 is equal to 250 plus 4P1 minus 5P2. First you have to determine the 4 marginal demand. That means you have to differentiate, okay, this function with respect to P1 and P2, and you have to differentiate this one with respect to P1 and P2. Okay, so this is the marginal demand of product 1 with respect to P1, which is minus 5. Because this is the constant number, derivative of this one will be 0, this will be minus 5, and this will be also 0, because this is here when we are finding the partial derivative of this function with respect to P1, then P2 is constant. So that's why 6 P2 both are constant number, so it will be 0. So that's why delta Q1 by delta P1, it will be minus 5. Similarly, if I want to find out the partial derivative of this function, that means the marginal demand of product 2 with respect to P2, it will be also negative 5. Why? Because this is constant number, it will be 0. Here P1 is constant, so this part will be also 0, and the derivative of minus 5 2 will be minus 5. Similarly, we can find out delta Q1 by delta P2. Here since P1 is constant, this will be 0, this will be 0, and then this will be 6, the derivative of 6P2. Similarly, here when we are finding the partial derivative or marginal demand of Q2 with respect to P1, then this will be 0 because constant, and this will be also 0 because constant, and the derivative of 4P1 will be 4. Now you see that delta Q1 by delta P2 and delta Q2 by delta P1 both are positive. Okay, you see that these two are positive. So that's why product 1 and 2 are competitive.